Good evening, everyone. Welcome to the May 2022 edition of Geek Night. As Anushi mentioned, extending Kubernetes using CRD and operator pattern. So CRD or custom resource definition is one of the powerful features that was introduced in Kubernetes version 1.7. This enables users to add their own custom objects to Kubernetes cluster and use it like any other native Kubernetes object that we use today. For example, pods, services. Today in this session, we are going to discuss some of these aspects related to operator pattern and CRDs. We'll also see how we can add a custom resource to Kubernetes cluster, how we can add functionality to that custom resource using custom controller, and how all this works together. So who am I? Anushi has already introduced me as well. So I'm Gopal Singhal. I did my PhD in computer science and my subject was web mining at scale using cloud. Currently, I'm working as a lead infrastructure consultant and also playing additional role of community lead, infrastructure community lead for ThoughtWorks India. I have close to 18 years of experience in industry. My interest areas lies in everything as code. Maybe because I'm lazy, I don't like to repeat manual stuff again and again. And also cricket, which is I feel the most popular sports in India. And last but not the least is flying. That is not so common thing. I have done commercial pilot license as well, which I got back in 2008. I have also shared my coordinates if anyone is interested in connecting with me. So let's jump on to agenda. So this topic we have for today, CRDs and operator pattern is a bit vast topic, and it is not easy to cover a lot of this in 1 hour. Our goal will be to cover the basics to ensure that anyone who is not familiar with this concept can get an idea about it and then can enhance their knowledge by referring back to other resources available on internet. So this you can consider it as a get started kind of guide to CRDs and operator patterns. So to start with, we'll do a quick recap of Kubernetes architecture and its reconcile loop. Then we'll go with laying down the foundation of CRDs and operator patterns, like what it is and how does it work. And then at the end, we'll go with demo and also touch upon some other extension patterns which Kubernetes provides other than the operator pattern. Okay. So most of us might already be familiar with Kubernetes and might be using Kubernetes in their projects as well. But since this topic is based on the core foundation principles, concepts of how Kubernetes reconciliation works, it is good to have a quick recap to understand what Kubernetes is and how does it actually work. So if you see Kubernetes is a orchestrator for any kind of container workloads. It could be pods, replica sets, deployments. All these are different types of workloads providing different features and capabilities to the workload. And how does these objects provide capabilities? So all that logic falls under controllers. So that is one of the core component of Kubernetes cluster. And as you see in the diagram, we have Kubernetes control plane where we have API server, schedulers, etcd, and control manager. So API server is is the only entry point, or would say component which provides connectivity to all the internal and external entities. So whether we are using kubectl or connecting it through dashboards or APIs. So for all those communication, it starts through API server. And same with the internal components like kubelet, scheduler, etcd, control manager, everything which requires any information related to the workloads or objects connect through API server. Now, etcd is the only persistent storage component in the whole cluster. Rest of the things um, are non-persistent, or like those are like stateless components. etcd stores all the information, all the metadata related to workloads. Whenever there is a request to API server for a workload, it gets stored in etcd. And then controller manager checks if there is any differences in the desired state versus the current state. Then it identifies that and tries to bridge that gap. Then scheduler picks those requests and identifies which nodes have capacity to run the workloads, and then schedules the workloads on corresponding nodes. So this is a high-level overview of how Kubernetes works and some key components of Kubernetes cluster. So these four are not the only components. There are many more components related to networking, DNS, but since those are not too relevant to this topic, so we have skipped them for today's discussion. So reconciliation loop. This is the core concept of Kubernetes functioning, and it can be divided into three phases. One is the observe phase. Observe phase observes the system for any changes in desired or current state. Next is analyze or the difference phase. Here, the controller checks that the resources objects desired state or specifications reflects the current state in the cluster, and if that doesn't match, then it creates a diff, and then comes the final phase act, which makes the required changes to bring the resources objects to the desired state. And this loop continues on and on. And this is something that is the responsibility of controller to continue on this loop and ensure that any object that is defined in Kubernetes, its desired state and current state meets. So we just recap Kubernetes and its reconcile loop, and we just saw that Kubernetes gives a lot of features in form of object to manage application workloads, but in few scenarios these may not be sufficient. We may need more. We may need to perform complex operations than what we just saw. We may require to do some backups, restore some configuration of applications running in cluster like databases or some other clusters that require synchronization, reshuffling of data from one working node to another node, handling failovers. So these are few scenarios where we struggle to like use native objects provided by Kubernetes and need some additional functionality to achieve these things. And to achieve these things, we may need to involve one or more items listed here. Like either we can extend functionality of existing objects like deployments, stateful sets. We can add new concepts or new functionality to the cluster, and one of them is CRDs and operators that we'll talk about. You can automate administration of cluster application, replace existing cluster components, similar to like the first point, which was about extending the functionality of existing components. On top of that, we don't We don't want that these additional features are like are managed by someone else. We may want them to be managed by us so that we can customize them as and when needed based on the requirements of our application, the requirements of the way our infrastructure is set up. And since these kind of features are not very generic enough, these cannot be included as the core Kubernetes platform. It has to go as something that can be plugged into Kubernetes to provide this additional feature. So for all these challenges that we just saw, we'll learn about operator pattern and how we can overcome those challenges using operator pattern. So I just talked about operator pattern multiple times, but the slide says custom resource definitions. So operator pattern is nothing but a combination of custom resource definitions and custom controllers. So we'll first talk about custom resource definitions and then see custom controllers and then see them working together. Now, what are CRDs? So as I mentioned earlier, like I think while introducing this presentation, so CRDs or custom resource definition is a feature that enables users to add their own custom objects to Kubernetes and use it like any other native Kubernetes object. So we just saw some native Kubernetes objects like pods, deployments, replica sets. So same way we can have our own objects, whatever name we want to call them. For example, Prometheus cluster or MySQL DB or PostgreSQL DB, and these CRDs lets us like extend the Kubernetes API to define our own objects. These resources are the endpoints in Kubernetes API that stores collection of the objects. As I just mentioned, like we have some inbuilt objects, and then we can have similar object created by our own, like through custom resources. And then the rest of the life cycle remains the same. The way, for example, deployment, we define a deployment kind of object. We use kubectl to apply that YAML and that gets deployed or like starts running on the cluster. Same way, when we define a custom resource definition, we define a custom resource in form of YAMLs and then use kubectl to apply it, and it actually runs the object or resource on the cluster. So you can create a custom resource anytime to the cluster whenever required, and it need not be something that has to be deployed at the beginning of setting up a cluster. So if I have a cluster running and I need a custom resource, I can add it at any point of time. So it's not a part of installation of cluster. As I mentioned, like custom resource definitions are defined or described in YAML files, similar to other objects in Kubernetes. And as an administrator, we just need to like add these CRDs like in YAML form and apply to the cluster. Operators, though, will be explained in the next section. So they use these CRDs to extend the Kubernetes API with their own functionality. So in a nutshell, anyone can create CRDs, add them to the cluster, and then use them. For that, you just need to create YAML file and just apply that using kubectl. CRDs, you can create new resources, and even you can rewrite the existing resources. You can override them. So, for example, deployment, though it's an object provided by uh, uh, it's a kind provided by Kubernetes, we can still override it and have our own implementation of deployment object. And then if we create an object of kind deployment, then it will behave the way we want it to be. So today, after having the overview of custom resource definitions and operators, we'll also see how they work, and then go through the code and even see them in action. So let's jump on to the YAML representation of custom resource, how it looks and how we can define a custom resource in Kubernetes. So it looks familiar, just like other files in Kubernetes world. CRDs are also created with the help of YAML and consist multiple fields uh, which define the custom resource, what kind of properties it should have, the coordinates through which it can be identified. And some of the important ones are listed on the left, for example, API version. So if you see the second last line kind, that is custom resource definition, that kind of resource is available in API extension.k8s.io/v1 version. So whenever we are creating a custom resource definition, that is the API version that we need to use as of now. In future, there could be new versions, some upgrades that's possible, but as of now, that's the API version in kind. Next is metadata.name. So that is the name of CRD that we are creating. It's a combination of the plural form of the custom resource that we want to create and the group. We'll talk about both of them in other like in the next few sections. Yeah, so spec.group, that is listed over here. If you see stable.example.com, so we can group multiple CRDs into one, especially when those are related. So for example, if we are creating a Prometheus Prometheus operator, then there are options like we can have Prometheus cluster as a CRD, we can have alert manager as a CRD. So those all can be grouped under Prometheus.com or something like that. So all these custom resources can be identified through a single group. Next is spec.version. It holds different versions of custom resources that are created. So over here it's V1. We can have alpha, beta as well before we actually go to the proper releases. Spec.scope. There are two options in scope. One is clustered scope or namespace scope. So for example, pods deployments, these are namespaced. So namespace is the default scope object, default scope for CRDs. If we want to create a custom resource that has a scope of clusters, then we can change the scope from here. Change the scope from namespaced to cluster. Next is spec.names, and over here we can see that the different form of names are defined over here. We can have plural form of the name, singular form, the short name, and the kind that will be used in the custom resource definitions that will in the custom resources that will actually use this. Plural, singulars, and short names are usually used when we are using APIs or kubectl to query or run some operations on this. Okay, now let's try to create this CRD, just this one that we just saw, and then we'll create a custom resource of type cron tab and see it in action. I may have it already set up, so I'll delete it first and then create. I hope you can see my screen.
Yes.
Okay, so over here we have the same YAML file which we just saw in the presentation, which defines our cron tab custom resource. Over here we have the properties which are required for the operation of this object, the cron spec or image that we want to run, and the replicas. And it has these are the names that are defined for this. Now let's try to apply this. So it's saying that it's unchanged because this definition is already there. We can delete it. And then let's try to apply it again. So it's saying that it's now created, and now let's try to get the CRDs that are available or created on this cluster. So if we see the second one, that's cron tabs.stable.example.com. That's the one that we just created. It's saying it was created on 12th of May. And now if we try to do get cron tabs, so it's saying no resources are there. Now let's create one. Over here, I have defined a resource or an object of kind cron tab. This is the name I have given to it. Then a cron expression and the image that it should run. Now let's apply that. And now if we do get cron tabs, we can see our cron tab is there. Yeah. Okay. So let's go back to the presentation. I think something is wrong. I'm not able to go there. Do you see the presentation? No?
No. The desktop screen is visible now.
Yeah, looks like I removed it by mistake. Let me open it again.
Hey. Okay.
Sorry about that. Okay, so we just saw how we can create a custom resource. It's no like we don't need any any programming skills to create a custom resource definition. It's simple YAML. We defined the custom resource definition using this YAML, and then we created custom resource of this kind again using YAML. But this definition or that object that was created has no functionality behind the scene. What is happening is when we are creating this custom resource definition or creating that custom resource, it is just storing, like making an API call and storing that information in etcd. That's it. Since we do not have any controller in place which can act upon it or which can compare the desired state versus current state, no action is taken. And here where we need the operators. So operators are where the things gets really interesting. So we just started with CRD adding CR, but saw that no action was taken, just saw that things got created, but nothing happening. Over here, like operators comes into picture. CoreOS, they were the first one who coined this term operator pattern in one of their articles. So the link is here, coreos.com/operators. And in this article, they talked about the custom resources and custom controllers. So custom resources and custom controllers in combination are called operators or operator pattern. So custom resources and controllers in combination, they help in implementing all these complexities, and that's actually Kubernetes native, not something which is not visible to Kubernetes. So when we are using this pattern, the main benefit is that Kubernetes system is aware of what is happening, how things are set up and all, and hence we can use Kubernetes tooling to further query or manage these workloads. So in summary, operators are like clients for Kubernetes API that act as controllers on these custom resources. So an operator is a method of packaging, deploying, and managing Kubernetes application. It puts operation knowledge in the application, and once the operator is deployed, it can be managed by just creating custom resources using YAMLs. So deploying operators is a one-time activity, like similar to deploying CRDs. So once those are deployed, we can then just play around by creating more resources using that kind of custom resource. It provides mechanisms to handle all kind of complexities, and it is not something that I have to create it if I need it. Like there are third parties who are actively writing operators, and they can create operators and publish them to the platforms like Operators Hub, and people who are not comfortable writing or maintaining operators, they can use those publicly available operators in their cluster rather than like creating or maintaining their operators on their own. And some of the publicly available operators are like Prometheus, PostgreSQL, Vault, MySQL, and so on. Like there are a lot of operators that are available, and like when we use these operators, like all internal complexities are hidden behind the implementation. So when we define the resource for these custom resources, then we just need to like use them and define using YAMLs and just apply. So though we have already discussed this multiple times, but just to reiterate. So if we deploy a PostgreSQL container, maybe using pod, it will only start the database and that we can connect, but it doesn't provide any backups or any other complex functionality that we really need in a database. So there we can use database operator like PostgreSQL operator, and it will provide us features like replicas, failovers, backups, and like in replicas also we can have read replicas, write replicas, and all that. So all these complexities are inbuilt in the operators, and we can further extend the operators. We can pull in an operator from operators hub and then further extend it by adding more functionality to it as we need it. So we just now saw operators. Let's see a simple operator like which is combination of custom resource and custom controller in action. Let's move to demo. There we'll create an operator using KubeBuilder. I haven't introduced you all KubeBuilder yet, but KubeBuilder is a tool that can be used to automate the process of scaffolding the operator related files and objects. So rather than setting up the whole directory structure and file structure on our own, we can use KubeBuilder to initialize things, and then we can modify the required files as per our needs. So let's see that in action. Okay, something is not happy. Okay. Yeah. Let's create a new directory, Geek Night 22. Now, since it's an empty directory, we'll initialize the Go project here, and CNAT is a short form of Cloud Native Act. So act is a command in Linux that provides a functionality where we can run something at a particular time. So we are trying to create at operator here. So in that at operator, if we say, okay, do XYZ at some point of time in future, then it will do that. So similar to cron tab, but it's more specific to time rather than a pattern. Okay, we have initialized the project. Next is KubeBuilder. So KubeBuilder init domain Geek Night. So this is how we initialize the operator project. And if we do a listing here now, we can see that it has created a lot of files here. Main.go is there, and then some configuration, make files, and Docker file. And then we can create an API. So far, like we don't have any API, it's just a dummy project. Now, if we do create API, so here we are saying that we want to name the group as CNAT and version as V1 Alpha 1. If you remember, while defining CRD, we had to define a spec.version. So over here we are specifying it as V1 Alpha 1, and the kind is at. It's asking me whether we want to create a resource. Yes. and whether we want to create a controller as well. Yes. So rather than writing our own YAML for the resource and creating Go files for the controller, it has created uh, created an at underscore types. That is how that contains the structure for the resource, and then at controller, it's a Go code for the implementation of the logic behind the definition. Next, it says make manifest. Make manifest will actually convert this at uh, types to the CRD. Now I have created. I have like after this we need to modify these two files like at underscore types.go and at underscore controllers.go. So to save some time, I have already done those changes. I'll walk you through that. It's not. Yeah. So if we come to at type, so here. So this is the custom resource definition for ATS. As I mentioned earlier, the metadata.name is nothing but the plural form of the CRD name and then the group name. So if we see that group is cnat.geeknet.demo and then plural is ATS, that is. Yeah, here it's sorry. So plural is ATS, and that combination of these two gives me metadata name. And then we have defined the names. Over here we have the version, and then we have properties to describe this custom resource. And the key properties are command that we want to run at some particular time and the schedule at which that command should be run. So this is the CRD definition that was auto-generated uh, by the cube builder. Not everything, but it had some minimal code, and then we had to add these extra properties and some stuff um, to have those properties consumed in the controller. Now, when we come to the controller, again, when we run Cube Builder create API, it creates a skeleton with a reconcile function with no functionality. But over here, we had to add functionality for different phases. So, for example, pending phase, what we want to do, and then so we want to schedule some task, then running phase, and then when everything is done, then we change the phase to done. And at the end, we have this setup with manager that is providing a voucher for the resource. So this file like by default has just the skeleton, and then we had to like add all the functionality. So hence I thought of having it ready before before the time. Now if we go to one of the examples, here is the example. If you see the kind here is at, and we have given some name to it. So let's say 3, and then some schedule at which we want to run it. Let's give a past date time so that this command will to ensure to be run. Now, we have the code ready. We need to get this running. And so we just saw that we did some initialization and created API using KubeBuilder. Once we make the changes in Go files for types and controller, we need to run make install run. What it does is it connects this operator to our kind cluster or the Kubernetes cluster. So this is one way of developing the operator or testing an operator from local machine. But when we are ready with the operator, this is not the way how we actually deploy the operator. Operators are deployed in the same way as any other application. So it can be deployed in form of pods. If you want deployment features on top of it, so we can deploy an operator in form of deployment. So yeah. Now we see that my controller is ready. Let's try to apply that. DOM directory. So it's saying that add sample 3 got created. So if we query it, so we see that there are 3 such objects. We can what type of. So here we can see that we have this at dash sample 3 object, which is of kind at. And if we see the phase, it's done, and the command was echo tested, and the schedule was 2 days in past. So this is like very basic example where we just saw how it works. Let's move to the deck now. Yeah, I think we are running a bit slow. We need to move a bit fast. So yeah. Yeah, in this diagram, if you see that we have CRD on the left of kind to do, and then we have a controller as well. Now, similar to this, we created one CRD with kind add, and then created one instance for that CRD. Now, the controller that we deployed has a watcher that looks at if there are any new resources or if there is any change in current or desired state. So when a new resource is created, an event gets triggered and this watcher hands over the control to reconciler. and reconciler takes the necessary action. So in our case, it was to print tested, echo tested. So it prints that and done. This is how the overall workflow is, where um, uh, the controller and CRD in combination handles a custom type of object. Okay. Now moving on to the best practices. I like we have two more slides. I think we may need to overshoot time by a few minutes. But let me try to move fast. So some best practices, like develop one operator per application. So for example, in Airflow, we have MySQL and Redis. So when we are creating operator to set up Airflow, we should not try to club everything into one operator. I think for MySQL and Redis, there should be separate operator, because these are something that should be managed separately or independently. Next is use an SDK like KubeBuilder. So we just saw that there are some benefits of using KubeBuilder, where it is providing a structured way of creating an operator, and provides a scaffold where we can simply go and write our logic. Next is operations should be idempotent. So all the functions should be written in a way that those are idempotent. It should not create problems. Like if a subroutine is called, then if things are already done, it should not add anything or change anything if things are set properly. Use declarative APIs as much as possible, though there is an option of having the imperative APIs as well, but that requires us to set up logic and sequence of implementation. So try to use declarative APIs as much as possible. Compartmentalize your features via multiple controllers. So as a new developer, there is a tendency to put everything in a single controller itself. So for example, if I create a Prometheus cluster, I tend to set up everything like backup and setting up of like alert manager, all those things in the single controller itself. But ideally, those should be separated out as separate CRDs and separate controllers. Test your code, like this is nothing new. Like this is applicable for any code that we write, and CRDs or operators are nothing different. So our code should be testable and modular enough so that we can test it. Unit tests are always better than testing things once those are deployed. CRD should be versioned and backward compatible. Again, like we just saw that CRDs has a versioning structure, like where we define V1, V2 and all. Try to have backward compatibility. If not, then it's recommended to change the major version for the CRDs. Then set up proper monitoring and logging. This is again very important. Reason being, once we deploy the operator, if something is not working, until we have proper monitoring for all the pods, deployments, nodes, or even at cluster level, until we have all those monitoring and logging in place, it will be difficult for troubleshooting any issues. Okay, moving on to the last slide. Other extension patterns available in Kubernetes. So before we get to the extension patterns, operators versus controller versus Helm, I think operators versus controllers, most of you have already found. So controllers are something that works on native default objects or resources provided by Kubernetes, like pods, deployments, and operator is something that works upon custom resource definitions. Helm, it is in itself is an operator which provides a mechanism to club multiple YAMLs in form of templates and then provide values to those templates. So all of these are different, though at times we can get confused whether to use Helm or operator. So if there is good enough complexity that cannot be controlled with Helm, I recommend to use operators. But if it is just clubbing multiple resources into one set, then Helm is a good solution. Coming on to Kubernetes extension, so we just saw one of them, that is operator pattern or custom resource definitions. Kubernetes provides a lot of ways to extend it. It is such a platform which acts as a platform for any new extension that we want to make on top of it. Starting with cloud providers, I think initially till version 1.10, cloud providers were part of the Kubernetes controller manager, but then from 1.11 onwards, they came up with cloud controller manager, and now, like with cloud providers, we can customize on how Kubernetes can interact with clouds. So for example, managing load balancers, managing security, managing secrets, managing authentication. So all that can be done using cloud providers. Next is kubectl plugins. So we saw that we use kubectl standard commands like get, apply to interact with Kubernetes cluster, but Kubernetes also provides a way to extend kubectl by writing our own plugins, which helps us in adding custom commands and subcommands under kubectl. Then we have scheduler extensions. So scheduler is something that watches for the pods and nodes, and based on the labels or the resources required by pods, it assigns them and schedules them. So this default scheduler can be replaced entirely or even patched to add some custom logic on scheduling. Like we can have webhooks to prioritize some type of workloads over on some nodes and all. Then we have custom API server. Then we have a custom API server that we can write our own API server in complete and then have an aggregation layer on top of it. So the core API server hands over the control to our API server whenever it has to take an action on a custom resource. Then we can have admission webhooks that is something that that comes into picture like when a new resource request arrives at Kubernetes. So we can have admission webhooks in form of HTTPS callbacks to do something when a request has been received, like maybe some authentication, authorization, or even modifying the object itself. So at the admission controller level, we can modify the object before it gets stored to etcd. Other three, I think like people might be aware of: CRIs, CNIs, and CSIs. So these are additional interfaces. Those provide ways to extend how the networking can be managed in Kubernetes, how storage can be managed, how we can attach a different type of storage management system, and even different type of container runtime. So instead of using containerd, can we use Rocket or something else? So those can be handled through CRIs. So yeah, sorry for moving fast towards the end. These are some references or useful links. I think this you can refer to these sites to learn more about this operator pattern. Then we have Cube Builder book that you can go through to learn more about Cube Builder and Operators Hub, where you can find operators published by third parties and some best practice and a sample operator for Grafana. Yeah, that's pretty much on the presentation side. I see there are a lot of questions. Sorry, I could not answer in between because of time constraint. Let me try to answer them now. So there was a question on can you show us how to create CRD in YAML? So we already did that. Next is we are using Helm charts to deploy our services over the cluster. I am currently working on a POC to update some pod configurations on the fly by using Kubernetes operator. This operator will be triggered by a pipeline and it should update the config map of the active pods on the fly. Am I in the right direction? Yeah, you can definitely do that. Yes, if there is some custom computation that you need to do before things are stored in config maps or some other persistent layer, yes, operator is the right direction. But if there are not any customizations that are required, you can even club your workload with config map in a single Helm chart as well. Does it mean we can override default Kubernetes resources through CRDs like deployments of pods, etc., or only option is to extend it? So yeah, we saw that we can even extend the defaults, but it is not recommended until you really need the names that are used by the default objects provided by default resources provided by Kubernetes. So yeah, but technically it is possible. Okay, last is please share the code and commands. Sure, I'll do that. I'll share the code and command. Currently, it's not on GitHub, but this session is recorded and will be uploaded on YouTube. In the description, I'll add the GitHub path for this repo and provide the commands as well. Okay, those were the questions. Anything else I missed out? If no, thank you everyone.